Video 38. Rules of inference for quantified statements. So rules of inference, name of that rule. So first one, for all x p of x is equivalent to p of a for all a. So this is the first line is in general because for all x, so therefore this is called universal quantifier, from which we are going universal specification. For all means universal. Instead of x we write a for all a. This is called universal specification. Universal specification, abbreviated as US. Conversely, if we have p of a for all a, then the conclusion is therefore for every x p of x. This is what is called universal generalization. From a we go to x, generalization, which is UG. So similarly, there exists x p of x. If we have this, therefore the conclusion is p of a for some a, at least for one a. This is generalization to specification, but existential generalization to existential specification. Existential specification. This is abbreviated as existential specification, ES. Conversely, if we have p of a for some a, our conclusion is therefore there exists x p of x from particular element to general element. So this is called existential generalization. Existential generalization, EG. Existential generalization. So next we start with the problems on predicate calculus. Problems on predicate calculus. Problem number 1. Show that there exists x, m of x follows logically from the premises logically from the premises for all x, m of x, h of x. If h of x, then m of x. If h of x, then m of x, and there exists x, h of x. Proof. So what are the premises here? The premises are Premises means hypothesis, or for every x, if h of x, then m of x. And another premise is there exists x, h of x. What should be our conclusion? Conclusion is there exists x, m of x. So here we have proof goes like this: steps, reasons. First step, for every x premise, for every x, h of x, conditional m of x premise. For every x means this is universal quantifier. So for every x is there, we can go to specification, namely h of a. If h of a, then we have m of a for all e. For all e. So this is what is called universal specification. If h of a, then we have m of a for all e. Third one, there exists x, h of x. This is also premise. So from existential generalization, we go to existential specification, that is h of a for some a. This is universal existential specification from 3. Existential specification from 3. This is universal specification from 1. Now you have h of a for some a, but h of a, if h of a, then m of a for all e. Therefore this is also true for this particular e. Therefore we can apply modus ponens. If h of a, then m of a, you will get m of a for some a, not for all e. It is only for some a it is true, because h of a is true for only some a. This is m of a using modus ponens, in 4 and 2. For modus ponens is h of a is there, then if h of a, then m of a is there. So therefore now we will go to generalization. M of a for some e means there exists x, m of x by existential generalization from 5. So this is what is our conclusion: there exists x, m of x. So this completes the problem. So the premises imply the conclusion: there exists x, m of x. This completes video 38.